This conference will now be recorded.
Hey guys, this is Naveen here. Welcome back to Naveen Automation Labs. So, guys, very important topic, very popular interview question, and today we will learn about what do you mean by the big O of log n that I've already some big O already we discussed about in the previous video. That what do you mean by O1, ON, ON square, and ON cube. Today we'll talk about binary search and then why binary search in the worst case scenario, why it is O log of n, the logarithmic growth of that particular algorithm. And binary search algorithm is the most popular interview question. Almost every company will be asking this question. So guys, please prepare for that. It's very simple. It's super simple. I'm explaining you that okay, how exactly we can use the binary search. So binary search is a special algorithm that you can design either in C, C++, Java, or Python. We will be using Java, but the logic will remain same. So binary search is the finest way or is the simplest way or fastest way, I would say, because the time complexity will be O log n to find out a particular element as compared to, I would say, as compared to quick sort or as compared to bubble sort. Now, binary search is searching algorithm to find the element of a particular element where exactly the on which position it's available, right? And always remember, binary search will be performed only and only on sorted array. This is a limitation. If the array is sorted, then only we can do that. If array is not sorted, first we have to sort the element and then only we can do that. Now, how exactly it will work? So first, let me show you that how exactly it will work. So let me create an array over here. So through the diagram, it's really important to showcase, guys. So let's see, I have some elements over here. Let's see, in sorted array. Remember this thing. So I create, this is my array. Okay. In this particular array, I have some values. Let's see, like this. I quickly design like this. So I have some values. Let's see, 3. Then I have 4. Then I quickly write this is 4. Okay, let me write it like this. It will take time. So 3, 4, 5, 6. Then I have 7. Then I have 8, and the final element is 9. So these are my elements are available 3 to 9 in sorted array. You can see that it's already sorted. Then I have to find out that okay, where exactly 4 is available. So 4 is available over here, right? The 4 is available over here. So this is called the lowest index, and this is called what? The highest index. So lowest index right now is 0, and highest index is like this 0, 1, 2, 3, 4, 5, and 6. So highest index is 6 over here, right? Now my target is that for x equal to 4, my this is my key element that we have to find out that where exactly 4 is available in this particular array. Now it can be anything. It can be any element x equal to 4 or 9 or 7 or whatever. Or the length of the array, it could be anything. Right now, let's say I have taken only 3 to 9 elements. So 3 plus 3, 7 elements, let's see I have taken. So 0 to 6 means 7 elements are available over here. Now this is called low and this is called high, highest index. Now, what you have to do guys, first in binary search, you have to find out the mid element. So what is a mid element? The mid element is this 6, right? This is my mid element, I would say. How will you find out the mid element? Mid element is equal to low plus high divided by 2. So can I say that mid element you will get low plus high divided by 2. So you will be getting your mid element. Simple. Now, when you get your mid element, you have to point out that, okay, yeah, this is my mid element. So low plus high, 0 plus 6 divided by 2. What will you get? 6 divided by 2. You will be getting 3. So 3 is my mid element. So this is 0, 1, 2, and 3. So this is my mid element. After that, what you have to write in the best case scenario, let's see 4 is available over here. It means x is found. Assume that okay, 4 is available over here. So first scenario is that if x is equal to mid, right guys? If x is equal to mid, it means my element is found. Simple. No need to perform further. My element is available over here, right? So in that case, x equal to mid, then simple. Your element is found over there, right? In that case, what I'm going to do, this is the best case scenario that, okay, in the first attempt, you have found your 4 or your element over here. So the time complexity will be what? O of 1 here. But this is the best case. You never know that, okay, in the directly on the mid element, your element is available or not. So once x equal to mid, I'll compare the element x equal to mid. If it is found, then O of 1. If it is not there, then what I have to do, the second thing is we have to write, guys, that if x is greater than mid, okay, if x is greater than mid, then what will happen? So in that case, what will happen? X is greater than mid. No, 4 is not greater than 6, right? So if x is not greater than mid, then what we have to do? Okay, let me write the third more condition also. If x is less than mid, okay, if x is less than mid, two conditions are there. It could be greater than or it could be less than. So if x is greater than mid, guys, what we have to do? We have to divide this particular array into two parts, left side and the right side. So if x is greater than mid, then we have to pick 7, 8, 9. It means x is available at the right hand side of the mid element. If x is less than mid, it means x is available. This 4 is available at the left hand side of the mid element. Remember this thing, right? So let's see, this is 3. But where exactly in this case, where exactly my 4 is available? The 4 is available, 4 is less than 6. So what I have to do, I have to pick 3, 4, 5, 6. It means x is available at the left hand side. Okay. So what I'm going to do that if it is available like this, then I'm going to take only these 4 elements, 3, 4, 5, 6. So now I'll be ignoring 7, 8, 9 or 6, 7, 8, 9. I'll be ignoring. So my array will be only 3, 4, 5, but I won't consider 6. So this is, I won't consider this. Forget about this. So only 3 elements are available, 3, 4, 5. Now what is my low element? What is my lowest index? My lowest index is always, this is 0. And what is your highest index in that case? So highest index is equal to whatever the mid, this was my mid, right? This was my mid. So whatever the mid that you have, mid minus 1 is equal to your highest index. Can I say that? So highest index is equal to mid minus 1. This is my highest index, 3, 4, 5. Then I'll repeat the same thing once again. Whatever the step that I have written, still my 4 is available over here. Still I haven't found where exactly my 4 is available. Then again I'll divide into two parts. So again I find the mid, where exactly mid is available. Mid is available over here now, right? So 0, 1, 2, and the mid is available over here at this position. The moment I find my mid, the first condition is satisfied, x equal to mid. I have found my element. So this is the 0, and on the first element, my x is available. Simple, right? So it doesn't matter that how big your array it is. Now assume that, okay, I have to find out 8. Now x is 8. So what I have to do? X equal to mid? No. First I'll find the mid. Mid is 6. No, it's not equal. X greater than mid? Yes. 8 is greater than 6. It means 8 is available at the right hand side. So which array I'll be taking? I'll be taking 7, 8, 9 only. This array I'll be taking 7, 8, and 9. It means somewhere my x is available over here, right? So then in that case, what I'll do? If x is greater than then, I'll be taking the right side element, and now my low will be what? See, this is my 6. This was my mid element. It was pointing to this over here. So my low element is equal to mid plus 1. Can I say that? This is my low element, right? The lowest index is mid plus 1, and this is my highest element. Then I'll find the mid. Yes, this is my mid. I got my 8 and perfectly working. Okay. So likewise, you have to perform. So you can take any example, any big array you can perform. It's very simple to solve such kind of problems. Okay. So if you really want to find out what is the time complexity for x greater than mid or x less than mid, in that case, the time complexity will be what? The big O of log n. Now why? Why big O of log n? Okay. For this, we have to understand one more diagram. Let me write something. What I'm going to do that, again, I'm going to create some array over here. Okay, let's see. This is the some array is available. I quickly designed that. Okay, yeah, some elements are available over here like this. It's a huge array. Okay, assume that. Okay, having some value around 15 values are available. Assume that 0 to 15. Okay, some values are available. Let's see. Then we have 1, then 3, then 5, then 7, then up to let's say 65 elements are available. And this is 8, something like this in sorted array, right? So this is my mid element, and I have to check that. Okay, this is my, let's see, 64th element is available over here, or let's say 60th element is available. So this is my x, right? And this is my mid. So x is greater than mid, it means 60 is available at the right hand side, right guys? 60 is available at the right hand side. It means I have to go in this particular direction. So when I have to go in this particular direction, it means 60 is available over here. Again, I'll check what is the mid of this particular element. If the mid of this element is 60, I found my element over here. Perfect. And I'll keep dividing. What exactly I'm doing, I'll keep dividing my array. So first the size was 16, right? I have divided into two parts. Then I have divided into four parts. Then I have divided into eight parts. Then I have divided into 16 parts. And finally, I have got my array. So I'm creating a formula over here, right? Like this. So if you draw a formula, how do you draw a formula over here? I can simply say that, okay, that 16 elements are available. Let's see, right guys, 16 elements are there. So it means this is 16 multiplied by, I would say 1 by 2 is equal to what? I have divided into 8 parts. The first mid element. So 16 divided by 1 by 2, 8 parts. Then I'll be saying that, okay, hey, again 8 is divided by 2 parts. Then I'm getting what? I'm getting 4, like this, right? And so on. Same thing, I'll be saying that, okay, yeah, this is my 4 divided by 2. Again, I'm getting 2 over here. This is also fine. Then again, I'll be dividing this particular 2 by 2, and I'm getting only one single element is left now, and that is my element. So this is the worst case scenario I'll be reaching till over here. So what I have to do, I have to keep checking, I have to keep dividing my array. Whatever the resultant array is available, I have to keep dividing the array by 2, and then divide, and then we have to traverse, and then we have to check the element is available or not. If x is greater than mid, we have to go to the right side. If x is less than mid, then we have to go to the left side. If x equal to mid, I have found my element over there, right? So can I say that this, if I draw a formula out of this, so can I say something like this: 16 multiplied by 1 by 2, and then if you write a formula to the power 4, can I say that? It means I have found my element over here. Can I say something like this? 16 1 by 2. It means 2 to the power 4 means 16. 16 by 16, 1. Right? So can I write it like this? Similarly, assume that, okay, you have n number of elements. N elements are available, right? So how will you generalize a term if you have n number of elements? To generalize a term, guys, what will you write? You simply write n, let's see, n multiply by 1 by 2, right? The power k, right? To the power k. Let's see, k number of times you are dividing. So this is the formula that we have written, right? It means then we are getting what is equal to 1. If this particular formula is satisfied, it means we are getting the last element, whatever the element is left, that is my search element. Now, can I say that if n multiplied by 1 by 2 to the power k equal to 1, so can I say that something like this, that n is equal to 2 to the power k, like this, from this particular formula, simple mathematics, 1 by 2 power k. So 2 power k will be given to the right hand side. So n equal to 2 to the power k. So I can say it like this. Now, if I take the log from both the sides, left side and the right side, how do you take the log? I simply say that, okay, this is my log of n, right? log of n is equal to the log of base 2. See guys, I cannot write base 2 like this, but this is base 2 nk. Then can I write it like this? Log of n is equal to log 2 divided by log k, right? Divided by log k. So formula is coming like this if I'm taking a log from both the sides, right? Then what I'm going to do, I simply say that from this particular formula, I simply pass this log k to log n to left hand side. So can I say that log n divided by log, okay, or I would say divided by log 2 is equal to log of k. I can say that. So if I drawing a formula once again, it means log of n with base 2, right, is equal to log of k. So this is what I'm getting, right? Log of k. So can I say that from this particular formula, it means I have n number of iterations, sorry, n number of elements, base 2, it means q divided by 2 is equal to k number of iteration. So this is what I'm getting over here, right? So that is what you have to draw a formula at the time of interview, that log of n, number of iteration, k is equal to what? What k is denoting? K means number of iteration that you are performing. Every time you are dividing by 2, it means n number of elements are available. Divide by 2, number of iteration that you are getting, like this. So if you have, let's see, 16 elements are available. 16 elements are available. So log 2 16 is equal to what? 4 iterations that you are doing it. It means you have the array which is having one array I'm having. The size is 16, 0 to 15. It means 16 elements are available. So how many iterations we have to do? Only 4 iterations. 2 to the power 4 we have to do that. So you have to draw a formula like this. It means 2 to the power 4 is equal to 16 times we have to 16. It means 4 times we have to do that if we keep dividing by 2. So that's why we are getting 16, 8, then 4, then 2, and then. So how many iterations we have done? 4 iterations we have done to find out what? To find out the element over there, right? So if you take a log in a generalized term, what we say? Log, right? Log n number of elements. What is the base? Base is k. Okay, I would say base is small k or whatever. N is equal to what? Oh, sorry. Base is, I would say, 2. Number of elements is equal to number of iterations. So that's why we are getting this. So log n is very, very good, guys, as compared to what? If you see the chart that we discussed last time, okay, as compared to on and on square or on cube, which is much, much better. It is just like, in fact, it is better than O of n. So if we go back to our, let me check, yeah, this one. If we go back, if you see this is on, this is O of 1. Now, if I go to my O of log n, where exactly O of log n? O of log n is exactly over here, just like, just slightly above O of 1. So this will be my what? O of big O of log n will be placed over here. So which one is better? On or O log n, right? O log n is better because On is for single for loop, especially let's see an On square for bubble sort or two for loops or inner loop and outer loop that we have. In that case, every element has to talk with some other element. It means m by n matrix you are creating. But with O of log n, you are dividing and conquer. This is called divide and conquer approach. In that case, what exactly we are getting? We are getting O of log n, right? So binary search tree, whatever the example that I've shown you, okay, that binary search tree is having the worst case is what? O of log n. Okay, binary search, binary search is O of log n. Remember this thing, right? And binary search, if someone is asking you what is the best case complexity for binary search, the best case complexity is O of 1. Let me go back and come back over here. Okay, So yeah, let it be like this. So the best case means, okay, so guys, best case will be by O of 1, and the worst case and the average case will be what? O of log n, I would say. O of log n. Remember this thing. And you have to draw this particular diagram and you have to explain, I mean, draw this particular calculation. You have to explain why it is O of log n. So instead of exponential growth, this is just the opposite of exponential growth. Exponential growth is what? This O(n) cube, O(n) square, O2 to the power n. They will increase the exponential. The moment you get, so one example, if I say that, let's see, for you have 100 elements and you are finding around a specific element in 1 second. The moment you double the element, let's see, 100, let's see, for 1000 elements, not double, multiply by 10, you are taking only 2 extra seconds. I mean, 1 more second extra. So only 2 seconds. You add one more zero, it means 10,000 elements, you are taking only 3 seconds. With what? Log n. Big O of log n. This is the power of log n time complexity. This is the power of binary search. So binary search is very, very powerful. It should be on sorted array. Some example, let's see, when you debug the code, right? In Eclipse or whatever, binary search algorithm is used over there, where exactly the error actually is happening. That time the binary search will be applied over there. So it will quickly check where exactly the error is happening over there. A lot of libraries, they are using binary search. One example, people might ask you, give me a practical example of binary search. Think about it. How will you give a practical example of binary search? Assume that, okay, there is a book, 100 page or 1000 or 10,000 pages of book is there. In that case, what will you do? So let's see, this is a book. How to draw a book? Let's see, this is a book having multiple pages over here. Page number 1, page number 2, and up to 1000 pages are available over there. And you have to find out, let's see, a dictionary book is there, and you have to find out a specific word. Let's see, the word is testing, or word is data structure. And data structure is available, you don't know on which page. So what will you do? First, you will find out the mid of the element. So mid of the page you will find, and then you will check the mid of the element, whatever the page number of whatever the page word is available, it's less than or greater than. In that case, element is available at the left hand side, right? If x is greater than of mid of the element, it means available at the right hand side. Otherwise, it's available at the left hand side. So likewise, you keep dividing the dictionary, your page, and then keep doing that like that. Okay. So this is one of the example you can find out, right? Let's see one more example. You have a class in your college, or let's say your school. Number of students are available. Okay, these number of students are sitting like this. Number of students are available over here, and one student is having one pen. You have to find out, okay, which student is having that particular pen. You don't know which student is having. So what exactly you will do? You will divide this particular student in two parts, left side and the right side, like this. And the same formula you will be applied over there. You will be applying over there, right? And then you will ask this group and this group, who is having that pen. If this group is having this particular pen, it means you will come left hand side, otherwise you will come to the right hand side group. And then again you keep dividing this particular group into two parts, like this. And then only three students are there, and then you find out the middle of the element. This guy is having the pen. Okay, this guy is having the pen. So likewise, such examples will be, or such problems will be solved by binary search algorithm. Now, how will you write the code for this? So remember the graph, examples, time complexity, explanation with respect to array, and this particular calculation that I have shown you. Very, very important, guys, to explain, and why it is coming log of n. This is the most confusing time complexity. Most of the people, they don't understand why it is coming like this. Okay, so please explain properly. Now let's write a Java program for that. So I have created a class already, and we will quickly see that how can you write uh, um, okay, a binary search algorithm for that. So let me create one thing. Let me create a main method over here as well. Sorry, I forgot to create public static because people will ask you the code also, and the code is also very simple, like this. And what I'm going to do that I'm going to create um, an array. Let's see, my integer array is equal to sorted array, and then I'll tell you non-sorted array also. So let's see, I have something like this: 3 comma 4 comma 5 comma 6 comma 7 comma 8 comma 9 already sorted, right? And then I'll be taking the length. The length of the array is n is equal to, let's see, arr dot length, and I have to find out my search term is x equal to 4. I have to find out where exactly 4 is available in this particular array, right? Okay. So what I'm going to do that, okay, I'll be creating a generic method for this so that it can be used for any other element, not only for 4, can be any element. So let me write public static a void, and my method name is, let's see, binary search method, right? And this guy says that, okay, you give me the array. So fine, I'll give you the array. So let's see, this is my array. I'll be passing what is a search term, integer x, and then along with that you have to tell the low and the highest value also that you have to pass, int I and low, so that we can find out the mid of the element, right? Like this. Then I'll come inside this particular method. I quickly write a while loop. Always start with while loop and quickly check if your low, then only you will check if your low is greater than or equal to high. Then only I start my okay, while loop, otherwise not. Then the condition is true. It means low is equal to what? 0, 0, 2. How many elements are there? 0, 1, 2, 3, 4, 5, 6. 0 to 6. So condition is satisfied. Then I'll quickly find my mid of the element. Mid of the element is equal to what? How will you get the mid of the element? The mid of the element I'll be getting low plus whatever the high value is there minus low right now, and then you divide by 2. Okay, like this. Sorry, over here, divide by 2. Right. So low is 0, high minus 0. So 6 divided by 2, you will be getting a mid of the element. I got my mid of the element, and then I'll put a condition over here that, okay, if whatever the array that you are looking for, array of what? Array of mid. That's what I told you. If equal to what? If it's equal to x, that is my term. X is what? X equal to 4. I'm looking for 4. And the 4 is available exactly at the mid of the element. It means what? You simple write return mid. It means return the index mid. So if you're returning mid, mid is what integers are to write int over here. Then I'll put another condition that if array of mid, right, is less than equal to x, right? If it is, it means x is greater than array of mid. It means I have to go to the right hand side. So if you're going to the right hand side, your highest index will remain same, but you lowest index you have to increase is equal to mid plus 1. Simple. Because remember this diagram, mid plus 1, if it is available at the right hand side, so it means this will be my lowest. It means mid plus 1. So this will be my lowest index. So that's why that is what I'm doing, low equal to mid plus 1, right? Else, what you do? Else you do high is equal to mid minus 1. Simple. Let's see, x is less than array of mid, then you come inside the else part, and then high equal to mid minus 1. It means my x is available where? X is available in the left hand side. So this is what I have to do, right? I have to come in the over here. So my low will be this, lowest index will be 0, and highest index is equal to what? Mid minus 1. That will be my lowest index equal to mid minus 1. So that is what I'm doing. Highest index equal to mid minus 1. If nothing is getting satisfied, it means element is not there. So simple, right? Return what? Let's say return minus 1, right? So this is a simple logic. Let's see, I have written. So right now we have only one f. So let me remove this. You can simply write it like this. And let me remove this bracket also. Okay. And this guy is saying what? Add return statement. So a return I'll be adding, this return I'll be adding after pipe. Right? Now I simply call this particular method. So this method I'll simply calling it binary search. And what is the array? Array is this. X is 4. What is the lowest index? My lowest index initially is 0. And what is the highest index? Highest index is equal to n minus 1. So n minus 1 I'll be passing like this. And this guy will give you what? Return some integer. So I'll say that, okay, this is my result is equal to this. And I'll put a condition over here that if result what? If your result is equal to minus 1, it means element is not found. I simple write system.out.println. I simply say that element is not found. Otherwise, else system.out.println element is found at index which position plus whatever the result that you are getting. Right, guys? So this is my result that you are getting. Right. So let's see this logic is working or not. So shall I run it? So x equal to 4. 4 is available, 0 and 1. I should get 1. The first position, 4 is available. So run as Java application. Element is found at 1. Perfect. Now I'm looking for where exactly 8 is available. So first divide by 2. 6 is the mid element. 8 is greater than 6. So it will go to the right hand side. So let's see. 8 is available at the fifth position. So let's count. This is 0, 1, 2, 3, 4, 5. Fifth position. Now let's check the last element, x equal to 9. So it's available at the sixth position. Now I'll check, do we have 10? 10 we don't have. So we should get minus 1 and then it should say element is not found. Perfect. So my logic is absolutely working fine. But remember, as I told you, it will work only for sorted array. The moment I remove the sorting over here, so let's see, I'm writing, let's see, 1, comma 2. Now this is not sorted. And I'm passing, let's see, I'm looking for 3. This is not sorted. It's saying element is found is 0th index. But the moment I write, let's see, some 2, it's saying element is not found, but element is available over there. So it will work only and only for sorted array. If it is not sorted, what will you do? You will simply sort it. You simply write arrays dot sort and you sort your array once. So once your array is sorted, then you find out the element once again. Okay, x equal to 2. So element is found at, okay, 1 second, arrays dot sort. Okay, maybe we can write a separate sorting logic, but I don't want to write it over here. But let's see, x equal to 2 that we are looking for. No, so let me remove this. Let's not sort it like this. Let it be sorted array by default. Okay, let's not touch unnecessary because binary search algorithm, first rule is always what? We have to sort your array. Array should be sorted. So then only you have to write it. If you are using the unsorted array, first you have to sort it. Sorting logic, I'm not writing it right now because again, the video will be unnecessary. I have to increase, I have to write a sorting logic for that. Okay, so first you sort it, any sorting logic you can write it, and then you simply do that. Okay, guys, so that's all for this particular video. You do one thing, that you first sort it and then perform. Okay, either you use arrays.sort or you write your sorting logic over there and then you simply perform it over there. Okay, let me check. It is arrays.sort, array.length. Okay, so it's already sorted. X equal to 2 is element is not found. Now let's see if I'm writing 2 once again. Element is found at index 0. See, it got disturbed. It means the array is not sorted over here like this. So let it be like this. So it's simple, remove this logic. Okay, and remove this guy. So sorting part, you guys solve it, guys. Okay, so but at the time of interview, they won't say that, okay, first you sort it and then you find the binary search. Then you apply the binary search. It's not like that. Already sorted array. You can simply give the answer like that. Okay, let's assume that, okay, array is available. It's already sorted. And if it is not sorted, first you will be sorting it and then you will apply it. They are more focusing on this particular logic. They want to hear the logic and the time complexity. How will you calculate? So the time complexity for binary search will be what? For the best case, if the element is found, at the middle of the element. Let's see, the middle of the element is 6. If I'm passing x equal to 6, immediately I'll be getting it. No need to write some other logic over there. Element is found at the third position immediately. That is my mid element. That is the best case scenario. That is O1. Big O of 1. Sorry. The worst and average, I would say, will be what? We have to keep dividing until the element is not found. So the logarithmic of n, and the base is k, like this. The base is k. So I cannot write the base over here, but the base is k, like this. Okay. So remember this and the formula. And remember this particular logic also. It's very simple. Please practice, guys. Most of the time, at the time of interview, forget to write these two lines. That is the problem. And always remember, it's sorted array. Okay. Perfect. So I hope this is clear. With this thing, guys, we have covered what? With this thing, we have covered O1, O log n, O n square, and O n cube. Those things we have covered. There is one more, O n log n. That is also something where O of n log n, that you will be getting somewhere over here. That is, I would say, the graph. If you really want to create for this, it will be like this over here, somewhere over here. This is O n log n. O n of log n. So that I'll tell you later. This is O n log n. So O n log n, some examples like quick sort, merge sort, heap sort, and the worst case of tim sort. These are O n log. Shell sort and tree sort also. The worst case of tree sort will be O n square, but average case and the best case will be O n log n. Those are more complex search algorithms. Okay, so that I don't want to confuse you, that we will do it later. N log n. Okay, so difference between n log n and O log n. O log n is almost like O1, one of the best algorithm, time complexity. If you are reaching O of log n, one of the best algorithm you are writing. And binary search is one of the best search algorithm. Okay, guys. Perfect. So thank you so much for watching this particular video. I hope you guys are learning time complexity, algorithm, data structure, and everything from the series. And please cover these things. Otherwise, you will struggle a lot during interview. You go anywhere, Amazon, Walmart, Flipkart, Google, Microsoft, Uber, Ola, anywhere, or Netflix or NetApp. Everybody's asking the data structure, algorithm, time complexity, and all these kind of questions in your first round of interview. And if you're not able to give the answers properly, then you're gone. Whatever other programming things or your Java knowledge or your Selenium or automation knowledge is the secondary part, the second or third interview round. First part, you have to clear this. And if you can give the examples like that, if you can solve the problems, at least 70% of the problems like that, easily you can go through. They want to see your approach. Most of the people, they give up the first round and okay, no, I don't know anything about this. I don't know what is time complexity. I don't know what is O log n. I don't know what is binary search. So you have to explain, you have to talk to clear the first round. Okay, guys, so that's all for today. Thank you so much, and I'll see you in the next video. Keep watching Naveen Automation Labs, and please subscribe to the channel. Thank you so much.